So section 3.7 is where we left off. We talked about physical and chemical properties. Physical and chemical changes are related. A physical change is a change in which the chemical composition of the substance is not changed. Say you take a big 2x4, a 6-foot long 2x4, and you cut it in half. You saw it in half. Are the two pieces still made out of wood? Yes, they are. Have you changed it? You've changed it. It's not 6 feet long anymore, right? That's a physical change. So physical changes include changes in the physical state. If you melt something, if you freeze something, or turn it into a gas, or the shape, if you change the shape, like cutting it in half or something. A chemical change is the same as a chemical reaction. In a chemical change, the composition of the substances is changed. So if you take that 2x4 and throw it into the fire in your fireplace, assuming you know, it's a burn day and you could actually light the fireplace, but you throw it in there and you burn it up. Is what's left still wood? Could you build something out of it? No, it's a pile of ashes, right? You've changed the composition of that 2x4 by burning it. That's a chemical change. Okay? So chemical change, physical change. There are some things that we can observe that help us to decide, is this a chemical change? So if you see gas being released, here there's a chunk of zinc in an acid solution, and we see bubbles forming. Bubbles forming are gases, and that's evidence that there is a new substance being formed. So that's evidence of a chemical change. If we see a release of light or heat energy, here I think this is, could be sodium possibly, or maybe lithium in water, and it generates hydrogen gas, and it also generates so much energy that the hydrogen gas ignites above the solution. And so we see what looks, fire, basically. So anything that's on fire is definitely a chemical change. A light stick, one of those glow sticks, you can go to the dollar store and buy a bunch of glow sticks for $1. And you bend them, right, and they go crunch, crunch, and then they start to glow. That's a release of light energy. That's evidence of a chemical change. There's a chemical reaction going on in that glow stick. If we see the formation of a precipitate, here's an example. We have this clear yellow liquid being poured into a colorless liquid, and we get a solid that's being formed. That solid wasn't there before. It's a new substance. There's a chemical change going on. If we see a permanent color change, that's also evidence of a chemical change. So, are the following chemical or physical changes? And one thing that you can ask yourself when you're doing a question like this is, can you get the original substance back? Has it become something new? So let's think about rusting iron. Is that a chemical or physical change? I heard mixed responses there. That is a chemical change. The substance of the iron is fundamentally changed. Rusted iron still has iron atoms in it, but it's not as strong as it was before. That's a chemical change. How about sugar dissolving in water? That's a physical change. If you evaporate the water, what would be left? The sugar. It's still there, it just mixed with the water, and so that's a physical change. Burning a log. Chemical. Burning a log would be the same as burning a 2x4. You're combusting it, you see light and heat energy coming out, that's evidence of a chemical change, and also what's left is very different than what you had before. How about melting ice? Physical. Anytime you see the name of a state change, melting, boiling, freezing, things like that, it's going to be a physical change. Because if you melt the ice, you could put it in the freezer and freeze it again and get the ice back, right? How about grinding cinnamon? That's physical. Cinnamon, you can see cinnamon sticks, and it's the bark of a plant. And ground cinnamon, you just take that bark and you grind it up into smaller pieces. The pieces are smaller, but they're still cinnamon, so that's a physical change. Any questions about those? On an exam question, I'll try to give you ones that are fairly obvious. Some of these questions can be a little iffy, especially for students who don't have a lot of science knowledge, so I'll try not to trick you. Just a quick word about these. These are evidence for a chemical change. They are not proof of a chemical change, okay? So they're a strong suggestion that a chemical change has gone on, but they're not proof positive. And you can also have chemical changes where there's no visible evidence for the change. So these are just guidelines.